Hi guys, welcome back. So in this week we'll be discussing the remaining three problems in Bargain A of OMK 2015 Muda, and we'll start with question 4. So here in the question, given an equilateral triangle ABC, so we draw as big as possible. Then we label this ABC. Then let P be a point on AB such that AP equals to 2/3 of AB, so it's somewhere around here. And then let Q be a point on AC such that AQ is 1/3 of AC. Okay, so it's somewhere over here. And then lines BQ and CP, they meet at R. So is there a way to draw a line of like this? Don't think so, but anything. Yeah. Uh, okay, so this is our R over here. And then the question asks us, so what is ARC in degrees? It's not the most accurate drawing, but I think can kind of get it. Okay, so look over here. So here's our 2/3. Since it's an equilateral triangle, so all sides are the same. Here's also 2/3, 1/3, 1/3. So basically we can say that because AB equals to wait, AB equals to BC. And then how should I say okay, then this angle A is also equal to angle B, so it's 60 degrees. And then AQ is also equal to PB. Both are 1/3 of the side of the equilateral triangle. So here we can say that this triangle BAQ is congruent to the triangle CBP. Normally, we will prefer writing the sides and angles correspondingly, and then we can write the reason why they are congruent. So it's SAS. Yeah, okay, so SAS. So being congruent means that these angles, these corresponding angles should be of the same value. So if we set maybe this is A, then this is A. So this one would be 60 minus A. Oh my god, I think I need to buy a pen. 60 minus A. Okay, so we have a, how should I say? We have a 60 over here. And then 60. So if we want to calculate this angle QRC, what we basically do is this 60 minus A plus A, which is again 60. Okay, here I would like to introduce a new geometrical concept called cyclic quadrilaterals. So wait, I'll write the abbreviation down. Cyclic, cyclic means circular, I don't know, in a cycle, and then quadrilaterals. Oh my god, this will take so long to write. Quadrilaterals. Okay, so basically what a cyclic quadrilateral is, a quadrilateral means a shape with four sides, which can be inscribed within a circle, meaning all the vertices of this quadrilateral all touch the circumference of the circle. So there are a few properties to take note of. The first one being this angle will be equal to this angle, and then this angle will be equal to this angle, and so on and so forth. There are four pairs. And then here's another one to notice. So maybe say take this pair. So take this red angle. So this interior red angle would be the same as this exterior red angle. So with these facts, I would like to try and use it. I don't know. I'll be using these facts to continue dealing with this problem. Okay. So, okay, what do we have here? This one should be equal to this one. So what do we have here? This 60 is equal to this 60 over here. So what can we conclude from here? We can conclude that this AP PRQ is in fact a cyclic quadrilateral, right? So um, uh, okay, so this APRQ over here is a cyclic quadrilateral. So what this means that wait if I were to find ARC, I could find it through finding ARP, which I could then find through finding this ARP. I could find through AQP. So what is the value of AQP? AQP, so how should I say? So, okay. So this should be a very familiar shape to you guys. This is an equilateral triangle. And then when I cut it in half, this is 90 degrees. So this one should be twice the length of this one. So our AQP would be 90 degrees. And then our ARP will also be 90 degrees. So what is ARC? ARC would be 180 degrees, which is a line, minus our ARP, which is 90 degrees. Okay, here we have our 90 degrees. So this ARC is 90 degrees. What a long question. Okay, question number 5. If we multiply together 16 fives and 5 16s, what is the sum of the digits of the product? Okay, 16 fives. So in index form, that will be 5 to the power of 16 and then times 16 to the power of 5. Notice one thing, okay, when you say maybe uh 10, right? So this is 5 times 2. And then this 100, which is 2 tenths, would be 5 squared times 2 squared. And then we have 1000, which is 5 cubed times 2 cubed, and so on and so forth. So, okay, dot dot dot. And then what we want to do is because this 16 to the power of 5, 16 itself is a power of 2, 16 being 2 to the power of 4, so 516 times 2 to the power of 4 to the power of 5. So at this stage, for the indices, you will have to multiply them. So which is 5 to the power of 16 times 2 to the power of 20. And then here you can break this down. You can break this 20 down into 16 and 4. 16 to merge with 5, and then this 4 as a standalone, which is now we have 10 to the power of 16 times 2 to the power of 4. Okay, so basically this is what is the sum of digits of the product? So 2 to the power of 4, which is obviously 16, and then 10 to the power of 16, meaning that here you will have 16 zeros. Okay, so 16 zeros. So what is the sum of the digits of the product? I think this is very obvious. Just add 1 plus 6 and then you get the answer 7. Okay, so done. This is a relatively quick one. All you need to notice is this part. I recommend you practicing with these. I don't know how you could, but yeah, just practice is perfect. Practice makes perfect. Okay, and now here we come to our last question of the day. So let x and y be positive numbers that satisfy these equations. Okay, so this is a very daunting one. So you can see this y minus 201 to the power of 5. Actually, substituting this term with any other term also makes sense, because as you can see that the upper part and the lower part is just like a double difference. I don't know what to say. So our main goal to here, if we want to find x, not what we want to do is to eliminate this y minus 201 to the power of 5. So how are we going to eliminate that? So x squared minus x. So we will double this one. So this is 10 and then 2000, right? So x squared minus 2x. So when I minus these two together, I'll get a 15. But then, uh, recall that we can make this x squared minus 2x plus 1, which is equal to 16. And then this x squared minus 2x plus 1, this whole thing is equivalent to, okay, so this 16 is 4 squared. Notice that x is a positive number, so yeah, so x minus 1 is 4, x minus 1 is 4, and then x itself would be 5. Okay, very nice. But how could we do so quickly if we didn't observe this at the first place? Normally, in this kind of competitions, maybe they'll come up with a very ugly looking, should I say ugly looking polynomial, and then the thing that you would like to do is to eliminate it. So just don't be bothered by it so much, I could say so. Okay, so yeah, here our answer would be 5. Okay, so this is our discussion for the day, and starting from next week for a consecutive 3 weeks, we'll be discussing about bar Gambit. So see you guys next week. Bye.